Hi, hello everyone. So last time we left off with this triangle, and the thing with this triangle is it was completely done. At least its data was written in a shader, and that's obviously not a good way to go around it. So we're going to try a different approach, and we're going to load this data, these positions, from the CPU, and then we're going to pass it to the GPU. So basically that's how your data will usually flow. You define it on the CPU, you usually get some file or something with the data, and then you load it to the GPU. But for now, we're just going to write that in some sort of a class, the geometry. But before we start with that, if I take a look at the coordinator here, this is a bit messy, these pipelines, because in the future, we're going to have multiple pipelines, and notice that I call this unlit. So we will have unlit materials, but and that means it's not going to have any kind of shading, right? In the future, we will do materials with shading, so the lights, for example, will affect it. And that's why we're going to actually start refactoring some smaller stuff, so just so that it's a bit easier to read. And for that, here I'm going to create a new group, and I'm going to call it, if I manage to write it here, render pipelines. All right. And then in our render pipelines, we're just going to do some small stuff. We're going to create a new class, I believe. So I'm going to call it unlit render pipeline. That's fine name. So we're going to need a metal kit, and then we can say class unlit render pipeline. We're going to have init, so we're going to need device, and I'm going to place underscore because I just don't want to deal with these names. And then from the coordinator, we're going to fetch this part from the shader library, render descriptor, creation of pipeline, and then setup of pipeline. So we can just save fetch that, paste it here. We got the device here, so we don't need to unwrap it. And here we're going to need, we don't need to unwrap it here either. And here we can actually grab this thing and then paste it here. And we're just going to say it's always going to be initialized. That's fine, and it can be let or no because of this guard statement. All right, let's just bring it back to what it was before. And then the second method that it's going to have is function draw. And then here as well, we're going to need, what are we going to need from draw? Notice draw here, so we're going to need these two. And then we're going to paste them here, and we're going to need this render path encoder. So I can say here safely with the underscore as usual. Render path encoder is of type mtl render command encoder. Render command encoder, that's probably fine. Okay, we don't need this question mark anymore. Everything is fine. Yeah, we can just rename this probably to render encoder. It's a bit easier. You can name it pass. I get this name from the WebGPU because I'm working sometimes with multiple APIs, and then stuff that there is these concepts and ideas, and stuff does the same thing. It's just named been differently, and then I get like all confused about it. It's just what it is. It's like somewhere the stuff that you pass in might be called uniform, but on the other DirectX it might be called constant, and you get these ideas which are always kind of same idea with different name, and then they're clashing. But anyway, I'm probably boring you by now. So here we're just going to have that unlit render pipeline. So I'm going to call it unlit pipeline. That's probably fine. And we're going to have this idea of pipeline, which is kind of same idea as a material. I'm just going to call it pipeline because it's a bit lower level at this stage. So I'm not sure if we're going to go higher level and define materials as well, but you can think of it as such. And then we can just create it here. So we can say unlit pipeline is what it is. It is unlit render pipeline. We create an instance, we paste the device, then we have to unwrap the device, and here we can just draw it. Unlit render pipeline, draw. I just call it unlit pipeline, my bad. And then we need to pass this render pass encoder thing, which will encode our commands. Alright, I think we are almost done. It's just, okay, it's not going to be nil. There is no reason for it. Actually, there is. And the reason is because this is in it. So it can be. So we can say here and unwrap this here. So yeah, I find this old safeguards rather annoying, to be honest, but it does make sense if you're working on a mobile or Mac app for which Swift is actually, it's kind of target language for those. I think it was inspired really by those and mobile development. Bit annoying when you're working with this, but alright, it's fine mostly. Okay, next we need to figure out what our data will look like and what we're going to pass to shader. So we can just create a new group. I'm going to call it here geometry, and I'm just going to create a new Swift class, which is our geometry. And here, this will be really simple. Abstract class, it can be whatever you want. And here we're going to create position vertices. So if it's of type float, so this will be our positions, and then when we're constructing geometry, we can also pass them in. So let's say we're going to need position vertices, and it's of type float. And then we can also initialize them to whatever is passed in, and that's regarding our geometry, which needs to be under folder geometry. And then we're going to create a new, not group, my bad, new file. It's also going to be the Swift file, and it's going to be geometry builder. So I'm just going to have class that can essentially build our geometry. Geometry builder, and here I'm going to say function, so create quad geometry. In future we're going to have cube, maybe some other geometric shapes, something just to represent the geometry, and we can say we have to return geometry. And then what we're going to do is set our indices, vertices, so our positions, right? I'm actually might call just positions. And for positions, we had them right here. So we're going to cut this, and then we can delete this as well. And then in our geometry builder, let's just paste it in and get rid of this float 4. So we don't need that. And then we can get rid of this 1.0. That's not necessary. That's something that you need to have in shader, right? I mentioned last time, it's homogeneous coordinates. It's used for transforms, but it also has its own use when it comes to projection, and we're going to deal with it. But for now, you don't need to paste it here. And then here we're just going to return geometry. So our position vertices is our positions, and that's it regarding geometry builder. Double expected type float. Okay, you just have to say here. We can say that it's of type float array if it complains about something, because usually for floats you need to add some kind of markup. But anyway, so now we just need to use the geometry builder to create our, well, basically our well, it's done via these buffers, right? And buffers is just it's basically some memory which is allocated from the CPU for the GPU, right? And so we're going to use those buffers to pass that data to the GPU, and I'm just going to call them attribute buffers. They're called attributes in some cases, like this small thing where it's it might be device buffer, it might be somewhere it's called attribute. I'm just going to get them geometry bits for now. And here I'm going to, we can have multiple ones, so we're going to just say geometry buffers. And don't think about these names, these are just names that I came up with, they're not that important. What's important is you're going to see it now. So we're going to need metal kit, and here we just say geometry buffer. I mean, it's called geometry buffer, but it's going to have multiple ones. For now, we're just going to have one, and we're going to have positions buffer. Buffer, if I could type, and it's of type metal buffer. Then we're going to have in it. So what do we need here? We're going to need a device, and then we're going to need geometry. And here we can actually now create that position buffer. And how do we create it? Well, we use device, and then we just make buffer. And there are multiple overloads. Here you see these ones, so we're going to use the second one with bytes. So here we could say bytes. What are our bytes? Well, bytes here, it's just the data that we want to pass in. So it's from our geometry, and then we had position vertices. And what is the length? So length is in bytes, so you just need to calculate the length. So it's going to be geometry, position vertices, count, and then what type did we use? What's the size of the type, right, that we used for positions? It's float. Float is basically 4 bytes or 32 bits. So if I bring this up, so we have these floats, right, and they have 4 bytes, but you can also have integers. They're also represented by 4 bytes, but then you have shorts, for example U16, which we're going to use, and it's comprised of 2 bytes, and then you have byte. How many bytes is byte? Well, it's 1 byte, right? So you have this idea of data, and then how many bytes does it have. So we're going to use 4, and so you could pass here 4, but you can also actually query for it via memory layout. And then you say float, and then you just ask for the size, and that's it. I think this should be fine. Device make buffer, I think we just need to unwrap it as usual. Yep. All right, I think we're good. So that's our position buffer. We have it right here. So what else do we need? Well, we don't need anything, we're just going to need to pass it in a draw method. So if we go to our unlit render pipeline, so we're here going to say our buffers. So it's geometry buffers. Our geometry buffer. Did I call it buffers here? And here I called it buffer. All right, I'm just going to add this. That's fine. So unlit render pipeline. So we're going to pass that in, and how do we pass it? So we got it from here, so we need to say render encoder set vertex buffer. So it belongs to vertex stage, right? Vertex stage is when we deal with basically vertices. So our buffers, we're going to use buffers, position buffer, offset. So usually you might want to offset. You don't have to start from the first element in an array, but in this case we want, and we will in most cases. And this index, I'm going to explain it in a second, so just pass 0 for now for index. And I think that's it regarding our and here we can actually get this from our geometry buffer. So we're going to set that. We're going to say here just a vertex count. So this is count of our vertices, and the vertex count is geometry position vertices over 3, y over 3, because per each vertex we have component x, y, and z per vertex. So we're just going to divide by that for reason of that. Float, okay, I just need to say count here. Alright, we're going to have this vertex count, then now unlit render pipeline, so we can say here buffers vertex count. Perfect. Alright, now last step that we need to do is we actually need to say here, so we just need to use these keywords and then paste that data in. So how we do that is we use const device. So device we're going to use it mostly when we work with this well, basically this attribute kind of buffer. So the buffers that are working something per vertex. There might be some other cases, but for now, when you see device here, you know that it's data per vertex. And then, so here is a bit of a kicker. You can use float tree, but you can also use packed float tree. And I'm going to explain the difference in a second, but let's just use float tree for now. Then because it's an array and metal shaders are C++ like, so it just place this as a pointer. So this star, and then we're going to say this is a keyword and this is specific to metal, and this buffer, right, that you see here, and this 0, especially this 0, it kind of needs to correspond to this index, right? So that's important. It needs to really correspond to this, because this is how you say which basically buffer is using which index. So it's sort of like an address, right? You're saying 0 here is actually corresponding to 0 here. And then we're going to have some other examples. And here we can just say this built-ins, so that we know that this is built in. And here I'm just going to say attributes or data per vertex. Okay, we have that. And here we're just going to say float 4 and pass 1.0. Float 4, right? Because this is float 3, and here we're just going to pass the position. So this float 4, when you see this, and I had good YouTube question in previous series about this, but the thing is with float 4, and when you use this float 3 for float 4, the constructor can take the constructor can take either well, it can either take float for x, float for y, float for z, and float for w, but it can also be constructed via float 3 and then float, or float 2 and then again float 2, or float 2 and then float and stuff like that. It has a lots of overloads, so just don't be surprised when you see something like this. So basically here you paste float 3 and then you place float. Okay, I think we might be even good here, so this might even work. Let's just try it. Okay, maybe not, because I'm missing second argument, which is obvious because I haven't created that geometry. So I'm just going to say here var geometry buffer is of type geometry buffers. It can be nil. Here we just need to create the geometry from our geometry builder. Then we had this create quad geometry, and then we're going to say geometry buffer is geometry buffers device was the first argument, and the second one is geometry, and then we can paste it finally here. It's an argument. I'm just going to unwrap it as usual, so now it should work. And it does. Alright, we're good here. So let's just do one small thing that I can explain now, and that has everything to do with these spec floats. So if I go to our shader and change this to float, save now and run it again, so it's all messed up, and the reason why it's messed up, it's actually easy. So you just have to be careful. So I'm going to return packed float. When using floats and packed floats, the thing is with the shaders in general, and you're going to see this quite often, it expects 16 bytes aligned stuff. So what does that even mean? But basically it means, let's say we have float 4 type here, right? You can see float 3 here, let's say float 4. So it has x, y, z, and double B. All right, that's fine. So what does it mean 16-bit bytes aligned? So it means that it uses 4 for this float, 4 for this float, 4 for this float, and 4 for this float. Okay, but what in case of float 3, right? And if you use just float 3, it's still 16-bit aligned, even though it has only x, y, and z in this case, right? And here it's 4, here it's 4, here it's 4. But additionally, it has something called padding, and that's 4. And then for float 2, you have x, y, and then you have padding, but padding here is 8, right? So here it's 4, here it's 4, and then 8. And the reason for this CPUs and GPUs apparently data, when you use it, it actually works better with this kind of memory layout. So that's the reason for this. And when you're saying packed float 3, you're actually specifying that it's 12 bytes alignment. If you just use float 3, then it's 16 bytes alignment. So it will result in something like this. For example, if you would use float 4, even if you paste it here, let's say let's say here we have float 3, so we get x, y, z. So first one is fine, but then for the second one, even if you're using float 3, it would actually continue with x, right? And then have another one, float 3, and then y, z, x, y. So this would happen with your data, right? The data that you pass from the CPU. So just be mindful of that. If you see message is 16, it requires 64 bits, 16 bytes alignment. It's everything that has to do with this kind of stuff. So just be mindful of that, and then let's continue further. Sorry to be boring about this. Okay, further, what we're going to need is go to our geometry, and let's try to create a plot here. So we had this for our triangle 1, and then let's just create triangle 2. And for the second triangle, if I take a look at here, what did we have? Okay, I moved it to another screen for some reason. We had this, so I can start from this corner, go here, and then here to create another triangle. So we're thinking top left, top right, bottom right. So let's go top left is minus 0.5, 0.5, 0.0, top left. And I'm just going to say top left here. Then we're taking top right, 0.5, 0.5, 0.0, top right. And then the last one we say bottom right, so 0.5, minus 0.5, 0.0, bottom right. So let's just try to run that. And it works. Perfect. All right, we have our quad. But now the next thing that I want to introduce here is something called index buffer. And index buffer, if you see here, this is actually dupe. We have it here, we have it here as well. So if I would just copy, so we copied top left, and then I also believe this one, which is bottom right. But with index buffers, we can actually avoid that. And let's just comment on how. So we're going to create here indices, and I'm going to use uint16. You can use also uint32. So you can either paste 2 bytes per element or 4 bytes per element. So I'm going to be 2, and the difference is the max number, right? When you're using uint16, you can paste usually 65,000 vertices, more or less. But now how does it work? It actually just references this. So if you paste 0, you're actually referencing this one. If you paste 1, you're referencing this one. And then if you paste 2, you're referencing this one, right? And that's our triangle 1. But now we can get rid of this top left and bottom right and just leave this data in. And here, which one was this? It was bottom left. But now for the second triangle, we can say something else what did we use? So we went from top left, so we can say here 1. Then we had top right, so 3, and then bottom right, so 2. So this is how indices work. You just reference the data in the vertex buffer, and usually when you have large model, this will save on data, right? Because these are first of all UN16, so less memory, and you also this one has X, Y, and Z proposition. This one just has one short. All right, and then we're going to pass them here. In our geometry, I'm just going to create those indices, and let's just say that we're always going to have indices, so that I don't have to think about it or create something, or not. Yeah, let's just say that it's optional. So indices, it's of type UN16, and then let's just say this vertices. Okay, and then we assign this indices. What is it complaining about? This can be only initialized once. So let's just say here that it's not initialized. Okay, so in our geometry buffers, so we're going to have another buffer. So I'm just going to call it index buffer. It's of type MTL buffer, and let's just say it can be nil. So when are we going to create it? Well, if we have some indices data, so if geometry that indices dot is empty, so, and here notice negation, so if it's not empty, then we're going to create this index buffer. So our index buffer is going to be same, right? Make buffer, so we're going to need this array paste in, so we're just going to say geometry indices, and then we also need length. So how do we get length? Geometry indices count times memory layout, and here we're actually going to paste int 16, or you can just say 2, both is fine. And that's it. And so we're going to need index count as well, and let's just say here by default let's just place it to 0, so it must be var index count is, so here we don't need to divide anything, we just paste in this as count. So that's our index count, and let's just create a bool also uses indices false by default, and if we have one, if we're using indices, we're just going to set true. And then last thing, so similarly how we paste these position buffers, so we're going to paste on this index or indices buffer as well. So we go to render pipeline, render pipeline, and here we're going to say if buffers that uses indices, we're going to do something else, we're going to draw as usual. And if we're using indices, there is this render encoder. We can say draw index primitives. So if you're using indices, you're actually using this overload. And here I'm just going to break this so that we can discuss each one of those. So primitive, same as here, triangle. We're drawing triangles. So you can draw also points, triangle points, lines, so you can experiment with that. So index count, we had it in our buffers, and we had this index count, so how many of them are we drawing? Index type, so I mentioned that it can be either unsigned integer of 2 bytes or 16 bits, or 4 bytes or 32 bits. So we were using 16, so we're just going to paste that in. So finally we need to paste that index buffer that we have created. So our buffers, index buffer, and I probably need to unwrap it. And then this offset is just saying, okay, we can skip first triangle, then draw. If you want to skip first triangle, you can just paste 3, right? Because then it skips the first 3 indexes which define the first triangle, but we actually don't want to do that, so we're just going to paste 0. And then if everything is alright, it should work all the same. So let's try it. Okay, once more, 22 other screen, and it works. So now we're drawing with indices, so just to confirm it, let's see if it's hitting here. Yes, the debugger is hitting here, right? Perfect. So we know that we're drawing with indices. And one last thing that I wanted to cover, sorry, I was just checking something. Last thing that I wanted to cover is basically we're just going to color differently this triangle that we had. Where are you? So here, this guy. So we're just going to do it a bit differently. So what we can say is here, if you go to coordinate, and here we had this color, right? So we're going to change this color a bit, and I'm going to use 0.8, 0.8, 0.8. So if I run it, we get this. That's quite alright, because these colors are going to be a bit different. So now we're going to use this idea of our attributes or device buffers to pass in another one. And this you can either use here float 4 or pegged float 4. I'm just going to go with pegged. And then I'm going to say colors. And here, what is our buffer index? Well, it's 1 now. So we're going to use buffer 1. Just place comma behind. And then instead of doing this, right, in our fragment shader, we're going to paste that in from the vertex shader. So we're going to say here float color. And then out color equal colors, right? And then we use this ID that we had also before. And then here we're just going to say in color. That will almost work, almost. We just need to define those colors and then create buffer for it as well. So we can say here colors, it's of type float. Here as well, colors, and then float is the type, self colors is colors. And finally in our geometry builder, let's just create some colors. Type float array. And we can do it like this: 1 0 0 1 for red, 0 1 0 1 for green, then 0 0 1 1 for blue, and let's just use something like this. I think it's yellow. If red and green are full, I think we get the yellow color. So then we're going to say colors here, and it's equal to colors. And in our geometry buffers, so we need to create that color buffer. So we're going to say here var color buffer, so tl buffer, and I'm actually always going to create it. I don't want to bother with this nullable stuff. So we can create it probably somewhere here. Our colors buffer is, you already know the drill, right? Make buffer. So we're going to need the second argument is bytes. So here we're passing geometry, colors, right? And then length is of type geometry, colors, count times memory layout. Which memory layout, right? Well, it's a float size. And then we can also wrap it here. And then final step is in our unlit render pipeline. Similarly to how we set vertex buffer here, we're going to do second one. We're just going to set index 1, and here instead of position buffer, we're setting a color buffer. If I run it now, it failed. Alright, because I'm missing a comma here, obviously. Alright, let's try again. It failed because I forgot the question mark here, and then it failed once again because, yeah, serves me right for copy pasting. Serves me right. So this needs to be var. Alright. Finally. Okay, so that's how we can pass in color. And these are obviously because it's only the vertex is colored. And so when you have the multiple vertex of different colors, it kind of linearly interpolates those colors in between. So here it might use 0.5 green and 0.5 yellow, so that therefore it gets this kind of color. But basically that's it for this video. So in this video, just to sum it up, we really learned the important stuff, which is kind of this idea of these buffers. And the buffers are nothing, it's just unallocated memory that can go to the graphics card from the CPU. And then you just need to somehow say, okay, where does it belong to, right? You have this idea of indexes. You can also call them IDs if you want, if it makes it easier. So it goes to vertex buffer, index 0, index 1, and then in vertex buffer, right? So if we take a look at it, we had this keyword device, and then our data as an array, we paste in buffer, and then the index of the buffer, and that's how we got the data in. Basically, that's it for this video. In the next video, we're going to deal with constant buffers and probably a bit on transformations and multiplying with matrices, stuff like that. So just that we can transform that quad to somewhere else to the screen. Basically, that's it then. Hopefully you enjoyed this video. If you enjoyed it, please like, subscribe, and if anything is unclear, you can always leave the question. You can also leave the question on Discord channel, and yeah, you can also reference the code that it's on GitHub. So therefore, until next time.